late, but it's better late than never, I guess. Here's the video. I'm not gonna. Oh, I'll try. All right, so we're looking for the first section here. Now, you already did number 1 with you guys. So number 2, sine of C, locate angle C. This is the opposite. I'll just write OP. This is the hypotenuse, HY, and this is my adjacent. So sine of angle C, right? The ratio of sine is opposite over hypotenuse. And they actually ask you to, what do you call? Simplify, so 3/5. Now you can change the decimal you like, but it doesn't say, but it's just. Alright, so the ratio of this angle here, right, the opposite, is 3 to 5. So for this particular angle, the opposite and the hypotenuse have to follow this particular ratio here. 3 to 5. 3, cosine of C, again. Sorry, cosine of C, so we don't need calculators this time, yet. Cosine of C, again, if this is the opposite, this is the adjacent, this is the hypotenuse, so cosine is adjacent over hypotenuse, so cosine of that angle, just call it theta. Cosine of theta is adjacent, which is 36 over the hypotenuse, which is 39. Okay, can we divide both top and bottom by 3? We can. We get 12 over 13. Cosine of C again, which makes this the hypotenuse, this is the opposite, and this is the adjacent. So cosine of C, let's just put C, 8 over 17. That's simplified already. Tangent of A, here's A. So tan of A, this is the opposite, this is the hypotenuse, this is adjacent. Tan is opposite, in this case 12 over adjacent, which is 35. Tan of X, here's X. Again, it will be, here's opposite, hypotenuse, adjacent. Opposite is 36, the adjacent is 27, all right? So you can simplify that, can you? We get divided by 9, 4 over 3. Okay. Just quick thing here, those of you still. So again, if this, we're talking about angle C, right? If you want to know, if you're still a little iffy on who the opposite and adjacent, so just make an arrow. If angle C pointed the opposite way, well, that makes this the opposite side. The adjacent is the side next to angle C, so this one is the adjacent. The hypotenuse, if you go to the 90-degree angle and you make an arrow pointing the opposite way, the 90-degree angle will point towards the hypotenuse, which is also your longest side. Okay? Okay, sine. So this is just a calculator exercise. Right, so sine is 62. So basically, think about this. There's a triangle. Let's put 90 degrees here. Let's just say this is 62 degrees. Right, so the opposite sine is opposite, hypotenuse, and adjacent. Right, so the sine. So they're saying if you take angle sine of 62, if you have a triangle, it's angle 62, and you take the opposite, which is this side, and the adjacent over the hypotenuse. That ratio there will give you a certain value, right? So in this case, we can use a calculator. So second function, pi button, or depending on what you're using, go straight to sine, enter 62, and we get 0.88294. We want to round this to 10,000, so we're gonna go up to here. So if you knew the if you knew the opposite and you knew the hypotenuse and you divided those two, this is what you would get in the triangle, where that angle there is 60. This angle here is 62. That's what you're looking for. Sine of 14. So again, here's a triangle. Here's your 14-degree angle. This is the hypotenuse, opposite, and adjacent. So sine of 14. So if you had a triangle, 90-degree triangle, that angle was 14, and you took the opposite over the adjacent, you would get a certain value. And in this case, you would get second function pi 1 14, enter, you would get second function, pi 1, 14, enter, you would get 0.2419. Okay, so that's what you're looking for. Cosine of 60, second function, pi 2, and then we enter 60, and we get enter, we get 0.5. Cosine of 31, second function, pi 2, 31, enter, we get 0.8572, rounded to near 10,000. Tan of 79, second function, pi 3, 79, enter, we get 5.1446. Tan 25, second function, pi 3, 25, enter, we get 0.4663. Okay. Find the missing side. Okay, so we got to figure out now which of the three trig functions we can use. So this is where the utility comes from. So tan 59, that makes this the opposite, right? So if you make an arrow there, that makes that not an arrow. If you point from there to there, wherever it's pointing to makes that the opposite side. So obviously this is the adjacent, and the hypotenuse is the longest side or opposite the 90-degree angle. I want to find the opposite, where that's where the x is. So opposite comes into play, and hypotenuse is a value that I have. Adjacent, I know nothing about the adjacent, so not very helpful right now. So anything that has opposite and hypotenuse, what would that be? That would be the sine, right? So sine 59. So if you have a triangle, a 9-degree triangle, and this angle is 59, there's a special relationship between the opposite and the hypotenuse. So opposite is x, hypotenuse 17. So that's what we're looking for. Well, we can cross multiply, so sine 59 times 17 equals x. And then let's go second function, pi 1, 59. So sine 59, 0.857167, etc. times 17. And we get that the missing side, x, equals 14.57. So this guy right here is 14.57. Now, just to confirm here, so we have the opposite as 14.57, and we have the hypotenuse as 17. So let's do this. So if you have your calculator, if you had the opposite side as 14.57 and you had the hypotenuse as 17, what would be the angle? So imagine if I gave you a stick, right, and where the hypotenuse 17 and the opposite here was 14.57, right? What angle would that make? Right? What would be this angle? Is it 59? It has to be 59. It would have to be 59. So that's what you're looking for. So second function pi, just to confirm, sine of -1, the inverse, sorry, is 1, and then, not 1, it's 4. And then we're going to enter 14.57 over 17, and hopefully you'll get something very close to 59. And you get 58.98. The angle is 58.9879, which is very, very close to 59. Right? So I can check this to see if we were correct. 14, angle 60. So this is the opposite, this is the adjacent, this is hypotenuse. I definitely need the opposite, and again, this is going to be opposite and hypotenuse because adjacent I have no value. So, well, again, it's sine. So sine of, sine of 60. Sine of 60 equals opposite over hypotenuse. Sorry, opposite being the x, hypotenuse being 17. Cross multiply, so we get sine of 60 times 17 equals x. So if you put this over 1, cross multiply. So second function pi 160 times 17, we get second sine. Sine of 60, enter. times 17, enter, we get 14.72. Next one, this angle 27 points that way, so this is my opposite, this is always the hypotenuse, and this is my adjacent. In this case, I want something that uses the adjacent and the hypotenuse, so it's cosine. So cosine of 27 equals x over 20. Cross multiply, get x, or sorry, get cosine of 27 times 20 equals 1 equals x. This is still sleeping. Second function, pi, cosine is 2, 27, enter, times 20. Or you guys can do this in your calculator a different way. X equals 17.82. 16, here's our angle, 51, which points this way, so that makes this our opposite. This is the hypotenuse, and this is the adjacent. So anything that uses hypotenuse and adjacent, because opposite I have no information, so this would be adjacent and hypotenuse, cosine. So cosine of 51 is adjacent, 10 over x, cross multiply, so we get cosine 51 times x. So this one's a little bit different, so we want to divide both sides by cosine 51. Right, isolate our variable, divide this by cosine 51, and x equals, so we're going to enter 10 divided by second function 2, which is cosine 51, enter, and x, our missing side, is 15.89. I guess I'm actually doing all of this. 17, again, start with labeling a triangle, angle 40. The angle is 40, points that way, so this is my opposite, this is my hypotenuse, this is my adjacent. So in this case, hypotenuse is not too good for me, so I want to use the opposite and the adjacent. So tan of 40 equals 20 over x. So we get tan of 40x times x equals 20. And divide by tan of 40. Divide this by tan of 40. And x equals, and whatever that is, 20 divided by second function, pi 10 is 3. And what is it, 10 of 20? 10 of 40, sorry. We get 23 point, rounded 84. Last one, again, the angle is 53, so going that way makes this the opposite. This is the hypotenuse, this is the adjacent, so we want, again, tangent. So tangent of 53 is x over 12, cross multiply, tan of 53 times 12 equals x. Second function, pi 353, enter, gives you 1.32704 times 12. We're going to get 15.92. That's the value of our opposite side of angle 53. Okay. Now find the angle indicated. Okay. So this, again, if you look at that angle, our missing angle, point that way, so that makes this the opposite. This is a hypotenuse, this is adjacent. So which one uses opposite and adjacent? That would be sine, right? So sine of our missing angle is the opposite, which is 39 over the hypotenuse, 44. But we want to find the angle here, so we're going to use this function in the calculator. So that one's actually number 4. Second function, pi. I believe that's number 4 on the yellow calculator. I don't know if you're using an iPhone, that's different. And then we enter 39 over 44. And our angle is the nearest degree, 62. 20, again, this makes this the opposite. This is the hypotenuse. This is the adjacent. So we want to use opposite and adjacent. So again, the sine of that missing angle, 26 over 33. Right? So in your calculator, this is the one that you're using, 26 over 33. And again, second function, pi, that's number 4, 26 over 33. And our angle is 52 for number 20. This one, this is my opposite, this is my hypotenuse, this is my adjacent. So we want adjacent and hypotenuse, so that's cosine. Cosine of a missing angle is 24 over 36. We want the missing angle, so we're going to do this, right? And second function pi cosine, that inverse cosine is 5, and then we enter 24 over 36, or 2/3, and our angle is 48 degrees. All right, so basically think about it. If you had a stick, you had these three sides. If you had to make this particular triangle, right, and this stick measured 36, this measured 24, and this was whatever it was, what angle would that make? There is only one angle that you can produce with those three sticks. Okay. Again, this one, this is the opposite, this is the hypotenuse, this is the adjacent, so we're going to use anything that has adjacent and hypotenuse. So the cosine of our mystery angle is 20 over 23. So in order to find the angle, let's enter that. The second function pi cosine, inverse cosine is 4. Nope, it's 5. And then we enter 20 over 23, and we get the angle is angle 30 degrees. That's the closest angle. All right. Okay. That's the opposite. That's the hypotenuse, and this is the adjacent. So this one is tangent. So tangent of our mystery angle is opposite over adjacent. So tan inverse tan over 33. So second function pi negative inverse tan is 6, and then we're going to enter 10 divided by 33, and we get 17 degrees rounded. Last one, again, this is the hypotenuse, this is the opposite, and this is the adjacent, so we're using tan again. So tan, mystery angle is 13 over 16, so tan 13 over 16. Geometry calculator, so we're going to get second function pi 6, and then we're going to enter 13 divided by 16, and we get 39 degrees. So our mystery angle there is 39 degrees. Okay, so we can go back and, I guess, forward with that function, right? You can find the side and you can find the angle. So again, this one, it's more direct. So instead of giving you the sides, they actually divided out those two sides for you. So here's a triangle, right? 90-degree triangle, and there's this angle x. If you take the sine of angle x and you divide the opposite and the hypotenuse, divide the opposite and the hypotenuse, you actually get 0.7547. That's what that's saying. Instead of giving you in this format, they divided that out and gave you that. So in your calculator, you're simply going to do this, and that should give you the angle. So it's the same thing we just did. So instead of entering as a fraction, we're entering as a decimal. Okay, so first one, 4 sine inverse sine is 0.7547, and we get 49 degrees. So this one is 49 degrees. second one, second function again, pi, so we're going to go 4, 0.540, enter, this is 27 degrees. This one, cosine, so again, 0.5736, so that's what you're entering. So second function, pi, so this is 5, 0.5736, enter, and this is going to give us 55 degrees. This one, 0.5, second function, pi, 5 again, and 0.5, and this one gives you 60 degrees. Degrees. Last two, tan, so second function pi, tan is 6, 0.6249, that's going to give us 32 degrees. And the last one, sorry, let me write that down. What angle would give us that? So second function pi 6, 0.1405, enter, 8 degrees, rounded. And the word problems. So word problems. First one. Did we do the first one? Yeah, I thought we did the first one. Here's an airplane. And it's going, so the altitude currently, so we know already the altitude, the height, 6,000. Over the ocean, directly over a coastline, at a certain time, the angle of depression to the coastline of the airplane is 14 degrees. How much further to the nearest kilometer does the airplane have to fly before it's actually over the coastline? So 14 degrees, not that much, right? So I'll make that 14 degrees. Ugh. So let's imagine that's 14 degrees. So this is, I guess, the distance that the airplane has to go from here all the way to here. Let's call that x. And this, the hypotenuse, we don't know. We know, okay, we have all the information that we need. So we want to find out x. What can I use here? So this is my opposite, this is my hypotenuse, and this is my adjacent. Right. So I have adjacent and opposite. So this one I'm using tan. So tan of 14 is x over 6,000. Cross multiply, we get tan of 14 times 6,000 equals x. So find what tan of 14 is, and then multiply times 6,000. And we get 1,000 to the nearest kilometer, 1,496 kilometers. So this distance here is 1,496. Okay, assuming I did it correctly. 2, from a horizontal distance of 80 meters, the angle of elevation to the top of a flagpole. So here's a flag pole, and if you're 80 meters away, the elevation to the flagpole is 18 degrees. So calculate the height of the flagpole. So this is what we want here, x. That's the flagpole. Hypotenuse is here. This is my opposite, and this is my adjacent. So this is another tangent problem, right? So tan of 18 is opposite x over adjacent, which is 80. So tan of 18 times 80 is going to give us the height of that flagpole. So tan of 18 times 80 is going to give us 25. So the height of that pole, is it? Are we rounding this? To nearest tenth of a meter. Okay, so 25. Actually, this actually becomes 26. Just 26. So the height of that pole, 26 meters. Okay. I don't know why they say it's a tenth of a meter when angle is 18. That's 80. Horizontal distance is 80. All right. Don't know why. All right, next. 20, 33. So a ladder rests against the side of the wall. So here's a wall of the building. So let's cut, and then we have a 9-meter ladder. So here's a ladder. That's 9, right? The bottom of the ladder is 1.5 feet from the base of the wall. Okay, so let me draw this a little better. So here's the ladder. Okay, but the ladder, that's the ladder. So the ladder is 9 meters tall. The bottom here, from the bottom, the foot of the ladder to the wall, this is 1.5 meters. Determine the measure of the angle between the ladder and the ground to the nearest degree. So I'm pretty sure we want this angle right here. All right, we'll call that x. What is that angle? Well, from that angle, this makes this the opposite, makes this the hypotenuse, and this would be the adjacent. Okay. So anything that uses adjacent hypotenuse, this would be cosine. So cosine of our angle here. So what angle? Right, that angle. So the ladder. Again, this is the wall, and this is the ladder. What is that angle here? That's what we're looking for. Right. That's what we're looking for. Cosine of x is adjacent, which is 1.5, over hypotenuse, which is 9, and then we're going to use the inverse, right? So 1.5 over 9. So let's enter that in the calculator. 1.5 over 9. What angle does this have to be so that when I rest my ladder, this distance is 1.5 and this is 9, right? Because if you think about it, if I take that ladder and push it out a little bit more, then that distance would not be 1.5 anymore, and 1.5 would be a little bit more. So at that particular distance, there's a particular angle that's formed, right, with 1.5 and 9, and that's what we're looking for. So second function pi, that's number cosine inverse 5, and then we're going to enter 1.5 over 9. That's going to give us 80 degrees. To the nearest degrees, 80 degrees. Okay. 34, the angle relation to the sun, where a tree can. Okay, so some of these, so there's a tree. Let me draw the tree. The angle relation of the sun is 68 degrees when the tree casts a shadow. So there's a shadow here, 14.3 meters long. How tall is the tree? To the nearest tenth of a meter. Now that's the British spelling, okay, or the Canadian spelling. The angle relation of the sun is 68 when the tree. So I'm pretty sure so this is the sun, right? So this would be 68 degrees. So this is the hypotenuse. So again, 9 degrees. Hypotenuse. Opposite 68 degrees is your x here, and 14.3 is your adjacent. So we're going to use tangent. So tan of 68 is opposite x over the adjacent side, which is 14.3. Cross multiply, we get tan of 68 times 14.3 equals x. So second function, clear. Second function pi, tan is 3, 68, enter. Then we're going to multiply that by 14.3. And the height of the tree is a tenth of a meter. It's 35.4 meters. Okay, so this is the height of the tree, 35.4. Wheelchair ramp is 4.2 meters long. It rises 0.7. What is the angle of inclination to the nearest degree? So wheelchair ramp, hang on a second. So the way I understand it is, here's your wheelchair, here's the ramp, okay? and that ramp measures 4.2. Okay. It rises 0.7, so this would be 0.7 right here. The height, right? It's a ramp. What is this angle? And that's what we're looking for. Okay, so according to that opposite of that angle, it would be this one. All right, this is your hypotenuse, and this is your adjacent. So something that uses opposite and not hypotenuse would be sine. So sine of x, right? Opposite over hypotenuse, 0.7 over 4.2. But we want the angle here, so we're going to use this. And let's see what angle that makes. Sine inverse, blah, 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 blah. It's number 4, enter. We're going to put 0.7 divided by 4.2. And that angle is, to the nearest degree, 10 degrees. Remember, it's a wheelchair ramp, so that angle, that can't be that high, right? It makes it very difficult for you to push or use your hand to go up that ramp. So 10 degrees is your answer. 36. Person flying a kite has released 160 meters of string. Nice. The string makes an angle of 27 with the ground. So here's the ground. Here is the string. They're saying that this is 27 degrees. The string, 166 meters. Here's your kite. Right? How far is the kite horizontally? And this is what we're looking for. X. Okay. So this is the opposite. Right? Here's a 9-degree angle, which means this is hypotenuse, which makes this your adjacent. Adjacent is not going to come into play, so we want anything that opposite and hypotenuse. That's still the sine. So we're going to go sine of 27. And it's opposite x over 76. So how much does this measures? How much does what's the height? What's x have to measure in order for this, right, to be 27 degrees? That's what you're pretty much saying. So cross multiply, we get sine of 27 times 176 equals x. Simple function. Hopefully you have a phone or something that has sines. So sine of 27 is 0.4539905. And then you can multiply that times 176. And the height of our kite horizontally. Wait. Hang on a second. No. Nope. Ignore. It says how far is the kite away horizontally. This is not it. This is what we want. So I'm going to start the problem again. Okay. Person flying kite has released 176 meters of string. So here's the kite. The string makes an angle of 27 degrees with the ground. Okay, so I can get that. Right, so there's the kite. That's 9 degrees. This has to be 176 meters because that's the string. And how far away is the kite horizontally? We want this distance, not this. All right, so that's incorrect. It says horizontally. So therefore, well, this is still the opposite. This is still an hypotenuse. And this is still the adjacent. But we want different functions. So we want not the opposite, we want adjacent and hypotenuse, so that would make it cosine. So if cosine of 27 is adjacent over hypotenuse, which is 176, cross multiply, cos of 27 times 176 equals x. Let's see if I get this right. Cosine of 27 is 0.8910065524, which you're going to take that and multiply by 176. And x equals, to the nearest meter, 157 meters. Okay. And that should be it. Let me just... Yeah. Okay.